Principles of Operating Systems, Chapter 10, File Organization and Management. The simplest, or least complicated form of file organization is the pile. With the pile structure, data is collected as it comes. Each record is a bunch of data. No requirement that it be the same size, that it be either that they have the same kind of description. A bunch of data, another bunch of data, another record that's a bunch of data, another record that's another bunch of data. The purpose of the pile structure is just to accumulate and save data. Records can have the different lengths, different fields, same fields in different order, because there's no given structure for the fields in the records. Each record and each field in each record has to be self-describing, has to have part of its data the description of what the data is. Since there's no structure, in order to search for data in a file with pile structure, the search must be exhaustive. Start searching and keep searching until you're done. The most common file structure is sequential. In a sequential file structure, all records have the same format. All of the fields are fixed length and in the same order. Since each has the same size, then only the values need to be recorded because the position can be computed. Each of the records has a field, usually the first field, called the key field, that's used to identify the record. Of course, since they're used to identify the records, the key fields have to be unique within a given file. The sequential file structure is especially effective for batch applications, and it's the only structure that can be used for both tape and disk. The sequential file structure does not do well for applications that do a lot of searches, since finding a specific record usually involves reading a lot of records before you find the one you're looking for. And it's especially problematic for insertion or deletion operations, since if you're going to delete a record, then you have to move up all of the following records. If you're going to insert a record, then first you have to move all subsequent records forward to create an empty space. And of course, if there's a large file, that can involve a lot of transactions. Typically, instead of inserting or deleting one or two records, what they will do is create a record of what they want to insert or delete in a separate file, a transaction file or a log file, usually with a pile structure. And then these transactions can be merged periodically, executed every once in a while, several at a time, rather than just one at a time. You can improve the access efficiency for sequential files by adding an index. An index is basically another sequential file where each record only has two fields. One of the fields is a field from the main data file, and the other field a pointer to a record in the main file that has the value of the identifier as the key field. The idea is for the index records to identify blocks of records in the main file. Using the index sequential access method, when you're searching for a record in the main file, you start by looking in the index file to find the index record close to the thing you're looking for. Usually the key value, the first key value less than or equal to the target value. The pointer from the index record identifies the first entry in a block that contains the one you're looking for. Then you go to the main file and start searching from that record, looking for entries in the block. The index file then has only relatively few records, and each entry only contains two fields. And each block contains relatively few records, only the ones close to the block the first identified. So that a search requires many fewer operations than the process of searching the entire main file. As with a dictionary, you start with the page with if you're looking for a word that starts with the letter X, then you find the page where the words starting with X begin, and then start searching on those pages. When you're looking for a word in a dictionary, you start by looking in the index to see what page the words beginning with the first letter in the desired word starts. So the first letter of the word serves as a key value for identifying page numbers in the dictionary index. Then, when you know the page number where the words are with that letter, you turn directly to the pages where those words are, and there it's a short search to find the word you're looking for. Although adding an index improves the efficiency for search operations, it doesn't do anything to help the insertion deletion operations. These kinds of problems can be addressed by an overflow file that works kind of like the transaction file used for sequential file structures. We simply add a pointer field to each record in the main file, converting then the main file into a linked list. The records in the main file are stored as a physically sequential list at the beginning, but the linked list structure lets records be inserted or deleted without moving subsequent records in the main file. When we add new records, they're put in the overflow file rather than in the main file. Of course, from time to time, the main file gets updated, brought back to its physically sequential status, incorporating the overflow file into the main file. Now, insertion and deletion operations also require updates in the index file, but the index file is much smaller than the main file, and so it's easier to update. You can get even greater search efficiency using multiple levels of indexing. This is particularly good if if the index file is quite large. You can build an index for the index file. A situation where this might be used would be a calendar file. The key field for a calendar file would naturally be a year, month, and date. You can build an index file for your calendar file with just the year and month. The year, locating the entry for the year and month, you find the location in the main file, in the calendar file, for the first date of that year and month, and then search through the main file. However, you can make another index, an index for the year-month file, where the key field would be a year and has a link to the January entry for the given year in the year-month index file. With the structure then, to find the calendar record for a year-month date, you start by searching through the second index file for the appropriate year. The appropriate year gives you the location of the year of that year, January, and you can search through, in less than 12 operations, find the year month in the year month file, index file. The year month then gives you the location for the first day of that year and month, and with that link you can find the first date, and then in less than 31 operations find the location of find the record corresponding to the year month date. With an ISAM structure, you're pretty much limited on how you can access the records using the index. ISAM supports one index. In our dictionary structure, it's pretty well structured for searches on words based on their spelling. But if you're interested in words that have 8 letters or words that include the letter Q, the index doesn't help much. You're stuck with an exhaustive search. The calendar structure that we discussed earlier allows you to search based on dates. But if you're interested in searching for holidays, the indexes don't help much. There are applications where what you're interested in is flexible searches on many different kinds of searches. In this kind of a situation, well, pretty much what you have to do is introduce several index files having keys in different fields in your main file. For a purely indexed file structure, you don't have to have the main file structured as a list, as in ISAM. You can have several indexes. The index files are lists. All of your file accesses are done using one index or another. With this kind of structure, each record in the main file has got to be referenced by at least one record in at least one of the indexes. Index files are used where you need to obtain information quickly. They support quick, efficient access. Searches are quick and easy, but the structure is more complicated than the others, and so insertion and deletions take a lot more time, are much more complicated, because your index files have to be updated as well as the main data file. Now you have two kinds of index files: exhaustive indexes. An exhaustive index is a list where every record in the main file is referenced by one of the records in the index file. A partial index would reference only some of the main records in the main file. In situations that require very quick access, the hashed or direct file structure is a candidate. For the hashed structure, records have to have a fixed size, and each record has to have a unique key field, or a combination of fields whose function together to form a key. The system uses a function, the hash function, to calculate a number based on the value of the key field. That number, calculated by the hash function, is the offset in the main file where the data record is going to be stored. File access is efficient, and since the system doesn't assume that the records will be stored sequentially, insertion-deletion operations can be carried out very quickly as well. Of course, from time to time, the hash function is going to provide the same value for two different records with different key values, of course. The records with the duplicate values will have to be stored in an overflow file that the system has to provide.